Hello everyone, myself Jagmeet Singh and I am working as an assistant professor in mechanical department in Chandigarh Polytechnic College. Today we will discuss the engineering material topics. The topics are cast iron and the steel. We will learn what is cast iron, different types of cast iron and their compositions and applications, as well as we will also learn the steel, different types of steel, their composition and applications. So I'm going to start the lecture. First is cast iron. Basically, cast iron is extracted from the pig iron. Pig iron is a raw material that used for making cast iron, steel, wrought iron in different furnace. Pig iron extracted from the blast furnace. Cast iron is extracted from the pig iron the where in the copper furnace where the pig iron is used as a raw material, and the uh, other material like wrought iron is extracted from Purdick furnace. So different types of cast iron. In this topic, we will learn how is cast iron classifies, what are the function of cast iron and their types. So first is cast iron is a ferrous alloy that is made by remelting the pig iron in a cupola furnace until it liquefies. The molten iron is poured into molds or cast to produce casting iron producing of required dimensions. The molten iron that extracted from pig iron is poured into the mold and cast to produce casting iron for the required dimensions. Based on the application of cast iron, the alloying elements added in the furnace differ. The different elements are added in the furnace to improve the required properties of the material. The commonly added alloying element are carbon followed by silicon. The other alloying element added are chromium, molybdenum, copper, titanium, vanadium, etc. So these elements are used to improve the property of material. They give the strength to the material for their uh, good working purpose. Next is the how is cast iron is classified. Based on the alloying element added, the variation in the solidification in the cast iron and the heat treatment used. The microstructure of the cast iron can vary depending upon the application and preferred mechanical property. Iron casting can be classified in the following. Depending upon the application and mechanical properties, the cast iron can be classified as following. There are the types of cast iron. You can see there is white cast iron, gray cast iron, malleable cast iron. So these are some types of cast iron. These so first of all, I'm start with white cast iron. What is white cast iron? When the white cast iron is fractured, white colored cracks are seen throughout because of the presence of carbide in bodies. While white cast iron is hard but brittle, it has lower silicon content and low melting point. The carbon content in the white cast iron uh, and white can form large particles that increase the hardness of the cast iron. The carbon contents is the main elements that added in the iron to increase their hardness. It is abrasive resistance as well as cost effective, making them useful in various applications like lift bars, shell liner in grinding mills, where surfaces of the pump. Next is the gray cast iron. Gray cast iron is most versatile and widely used cast iron. The presence of carbon The presence of carbon leads to formation of graphite flakes that does not allow crack to pass through when the material breaks. Instant as the material breaks, the graphite initiates numerous new cracks. The fractured cast iron is grayish in color, which also gives it the name. The graphite flakes make the gray cast iron exhibit low shock resistance. They also lack elasticity and have low tensile strength. Basically, cast iron is the brittle material, and they have lack of elasticity and very low tensile strength. You cannot use them for tensile working process or elastic purpose because they are brittle in nature. However, the graphite flakes give the cast iron excellent machinability, damping features, as well as good lubricating property, making them useful for many industry applications. Due to graphite, presence of graphite, there are the properties that improve the mechanical machinability of the material. Damping feature also good for lubricating properties that used in many industrial applications. The graphite microstructure of the cast iron has a matrix that consists of ferrite, pearlite, and combination of two. The molten gray iron has fluidity and they expand well during the solidification or freezing of cast iron. This has made them useful in the industrial industries like agriculture, automobile, and textile industry. So the microstructure of the uh, cast iron, gray cast iron, is the combination of ferrite, pearlite, or combination of both. That is very useful for application, industrial application. There are different automobile parts, different agriculture parts, and as well as they are also useful in the textile mills. Next is the malleable cast iron. Malleable cast iron is basically white iron that undergoes heat treatment to convert carbide into graphite. During heat treatment process, the white iron undergoes into heat treatment process and converted into carbide converted into graphite. The resultant cast iron has properties that vary from both gray and white cast iron. In case malleable cast iron, the graphite structure is formed into irregularity shaped spheroidal particles rather than the flakes that are usually present in the gray cast iron. So this is the microstructure that make it different from the gray cast iron. This makes them malleable cast iron behave like low carbon steel. There is a considerable shrinkage that resultant in the reduced production of cast iron as well increased cost. Malleable cast iron can be identified easily by the blunt boundaries. Next is the ductile cast iron. Ductile cast iron is yet another type of ferrous alloys that is used as an engineering material in many applications. To produce ductile iron, small amount of manganese is added to the molten iron, which alter the graphite structure that is formed. So basically, the main role in the form of different cast iron is different element that we are used during the molten state of the cast iron. The different elements act in different ways, the manganese in the ductile cast iron acted as a ductile iron. It make it ductile and useful for different applications. It alter the graphite structure into uh, various sections. The manganese reacts with oxygen and sulfur in the molten iron, leading to nodule shaped graphite that has earned them the name nodular cast iron. The malleable iron, ductile iron is flexible and exhibits the linear stress strain relation. It can be casted in various sizes into varying thickness. So the malleable cast iron is the ductile cast iron. So it can be it is used in different applications because it is ductile in nature. It has the elasticity property. So compared to other cast iron, it is used in various applications. Next, we will discuss the steel, different types of steel. Hanji, next is the list of important alloys of steel. The different alloy of elements of steel that improve their properties. We will discuss it. First is the silicon steel. Second is high speed tool steels, heat resistant steel, spring steel, stainless steel. There we will discuss their different properties and their uses on the behalf of their proportion of their elements. First is silicon steel. Silicon steel improve the electrical property of the steel. Silicon imparts fatigue strength and resistance of steel. Steel containing silicon is the main constituents, is more ductile than the plain carbon steel. Steel containing 3 to 5% silicon has very low magnetic hysteresis. Uses of silicon steel, steel with manganese 1%, silicon 2%, carbon is 0.2 to 0.6%, has very high elastic element and used for spring. So silicon steel basically main application is it is used for making springs with chromium 5 to 7%, silicon 2 to 4%, carbon 0.4 to 5%. Steel retain its hardness and resistance of oxidation even at red heat. Such a steel is used for internal combustion engine. So this is the difference of two varying elements. You can see variation in elements that added in the steel can improve different properties of the material. In this the steel with manganese 1%, silicon 2%, and the percentage of carbon is 0.25%, 0.4 to 6% is used for spring. Next is we changed the proportion of the different elements, like we added chromium 5 to 7%, silicon 2 to 4%, chromium 4.4 to 5%. That steel retain its hardness during the high temperature. So this steel is used for internal combustion engine parts. So the application of steel with chromium, silicon, and the carbon used for making internal combustion engine parts. Next is the silicon. If we change silicon steel contain 4.5, 2.5 to 4% silicon, the low percentage of carbon, magnesium is employed for making lamination of electrical machines. So this is another application in which we can change the proportion of different elements and use for different applications. 30% silicon content steel has a very high corrosion resistance and used for chemical industry. Chemical industry, there is the risk of corrosion resistance is more, where the 30% steel silicon content in steel used for making chemical industry is corrosion free boiler shells. Steel containing 0.6 to 1% and 0.75 to 0.95 manganese is used for structural purpose. So if the steel have the properties like 0.6 to 1%, silicon 0.75 to 5% manganese, that is used for structural purpose. Next is the high speed tool steel. The name suggests, from the name you can guess that this is steel used for tools. A high speed tool steel are widely used for cutting of metals where hardness must be retained at elevated temperature. So this is the main purpose of this steel, that it will retain itself at high temperature. These steel are obtained by alloying tungsten, chromium, and vanadium. So these main elements are used for high-speed steel, that is tungsten, chromium, and vanadium, and the another helping elements are cobalt, molybdenum with steel. This alloying produce metal with the remain hard at temperature at which normal steel become quite soft. The common analysis that 18% of tungsten, 4% of chromium, and 1% of vanadium with the carbon content 0.6 to 0.7%. So this is the main ratio, main proportion that used in the high carbon steel. You can see 18 ratio 4 ratio 1. So this ratio is used in high speed steel for making different cutting tools. The carbon content is 0.6 to 7%. This alloy is termed as 18 ratio 4 ratio 1, while the increase in vanadium to produce ratio 18:4 ratio 2 steel. So this is the different ratios dash works on different temperatures, improve the red hardness and the cutting ability of the material. Another class of high speed steel contain a low percentage of tungsten, in which the percentage of tungsten is low, is being compensated by the addition of molybdenum. Steel is this type being increasingly used these days. Next is the heat resistant steels. A steel which must be resistant to creep at high temperature must be molybdenum, silicon, chromium, impart a resistance to oxidation and scaling. So this is the steel that is used to resist the part of resist of oxidation and scaling. Steel which are satisfactory up to about 700 Celsius operating temperature are the main elements of carbon 0.15% maximum range. Silicon is 0.15 to 20%, manganese is 0.5% maximum range, nickel is none, and the chromium is 1 to 6%. So these are different constituents range that is used in the heat resistant steel. Uses the these are used in as rolled as forged condition, particularly for the walls of the internal combustion engine for higher temperature up to 1000 degrees Celsius. Steel containing 22% nickel and 60% chromium are used. Spring steel, next is the spring steel. Carbon manganese spring steel. The main constants are the carbon and manganese, where the percentage of manganese is 0.5 to 1% and the percentage of carbon is 0.45 to 0.65%. And addition we can add silicon 0.1 to 0.35%. These steel are quenched and tempered to give Brinell hardness is about 350. The Brinell hardness number is 350. Uses of these steel are, they are widely used in the laminated spring as a railway and general purpose. They are used for the laminated spring in the railway and some general purpose. Next is the hyper-eutectoid spring steel. The carbon percentage is 0.9 to 1.2%, silicon 30%, 0.30% maximum, magnesium 0.45 to 0.70%. These steel are all quenched and tempered at low temperature. They are used in the volute and helical spring, volute and helical springs. Next is the silicon manganese spring, whereas the composition of silicon is 1.5 to 2%, the main element in the constituents. Manganese is the 0.6 to 1%, carbon is the 0.3 to 0.6%. These steel are used for manufacturing railway and roll spring generally. Next is the stainless steel. These stainless steels are classified into two groups. First is the plain chromium or high chromium no nickel steel. Second is the chromium nickel steel. So first is the plain chromium or high chromium no nickel steel. Out of this group, the former has carbon percentage 0.8%, chromium 12 to 20%, while as the latter the C carbon is the 1 to 2%, chromium 12 to 20%, and nickel 2%. These steel can be heat treated. You can heat treated it and uses for different purposes. Used for die, walls, and culture. So these different kinds. This is the hard material where you can use it. Chromium steel. Chromium, nickel, steel. These steel are non-magnetic and cannot be hardened. So these steel are non-magnetic and cannot be hardened. They have varieties due to the varying contents of chromium and nickel respectively. The ratio is the chromium is 18%, nickel is 8%. So different ratio you can use in the different for different purpose. A small quantity of copper, tungsten, and molybdenum is also added in these steels. They have high resistance of corrosion and may be cold and hot worked, pressed, worked and brazed and soldered. The percentage of carbon in these steel is kept up to 0.5%. These steel are a poor conductor of heat and electricity. So all these are some steels with their different ratios of elements as the ratio increase or decrease, how they are converted into different applications. So that's all for the topic. Thank you.